The first hack I want to share with you is rewriting division problems as multiplicative inverse problems. For instance, you have the expression A divided by B. Now remember, there's no dividing, so to speak, in matrices. So we have to find creative ways to represent the same thing. What we can do is to use indices to rewrite the fractional part. So I can take this divided by B and we can rewrite it as B inverse. Hence the name of the hack. And we're going to multiply it by the numerator. So B inverse times A is the same thing as A divided by B. Let's look at some more examples. So I want to rewrite the expression AX divided by A. So I'm going to take the fractional part, this part, the divided by A, and I'm going to write it up as A inverse. So the divided by A becomes A inverse, and I'm multiplying it by whatever is on the numerator. So AX is on the numerator. So AX divided by A now becomes A inverse times A times X. Let's do some more. We'll have 5 divided by 2. We can write this divided by 2, write it up as 2 inverse, and we're multiplying that by our numerator 5. So 5 over 2 is the same thing as 2 inverse times 5. Let's keep going. We'll have P over 2. I'm going to take this divided by 2, write it up as 2 inverse, and I'm multiplying it by the numerator P. Easy. Let's keep going. Here we have PQ divided by P. Remember, there's no dividing in matrices, so we have to rewrite it. So I'm writing the divided by P, I'm writing it up as P inverse times the numerator. And the numerator in this case is PQ. PQ. Let's keep going. Look at this one, the last one. 7B divided by Q. There's no division in matrices. So I'm going to have to rewrite this part using the hack. Rewrite it as Q inverse multiplied by the numerator 7B. Hack number 2 is very simple, very simple. So it is the inverse property of matrix multiplication. So as it says, the inverse property of matrix multiplication. So A inverse multiplied by the matrix A is equal to the identity matrix. Pretty much that's it. And remember how we had to write a fractional matrix being represented? We had to write it up. Remember the previous hack? I can remove this and rewrite it as 1 over A, right? And then I'm going to multiply that by A, and that should give me the identity matrix. So if I'm going to work this out, this is what it becomes when I'm dealing with fractions. And notice that it starts to look like the identity matrix. But when you work this all out, you end up with 1. And remember that the identity matrix is simply 1, 0, 0, 1. So the hack says if you have the inverse of a matrix and you multiply it by the original matrix, you're going to end up with the identity matrix. And the next thing, anything times the identity matrix is that anything. For example, if you had A times I, that is to give you A. Similar to how you have 2 times 1, that's supposed to give you 2. So that is what the identity matrix does. Whatever you do, whatever you multiply the identity matrix to, you end up getting the original thing. Just like when you multiply 2 by 1, you end up with the original 2. So that's a little side tip to share with you. Anything times the identity matrix will give you whatever that thing was. And the inverse of a matrix multiplied by the original matrix should give you the identity matrix. Let's look at another example. So here we have B inverse, the inverse of matrix B, being multiplied by the original B. So what this does, they undo each other, and you simply end up with the identity matrix. So B inverse times B gives us the identity matrix. Let's try this one. C inverse C, what do you think that should give you? Should give you the identity matrix. Let's try another one. Let's go with D this time. D inverse times D should give us the identity matrix. So the inverse of a matrix multiplied by the original matrix should end up giving us that identity matrix. So those hacks become very useful when we're trying to solve for a matrix, a variable matrix. For example, solve for the matrix X in AX is equal to B. When I'm solving for X, it means that I want X on its own. So I need to remove this matrix A. And notice that they're etched up together, so that means that A is being multiplied by matrix X. So what I'm gonna have to do is to undo that multiplying by X, by A. So if I'm going to undo multiplication, it means I need to divide by that A. And what I do to one side, I have to do to the next side. Now, you remember, we cannot divide matrices. But what other way can we use to represent division in matrices? Remember the hacks? We can use the inverse. So I can rewrite this divided by A as the inverse of A, and I'm multiplying that by the numerator, AX. Same thing on the right hand side. I can rewrite this divided by A as the inverse of A multiplied by the numerator, matrix B. With me so far? And do you see the second hack coming into play? Here you have A inverse and A, the original matrix. These work out together to give you the identity matrix. So these together give you the identity matrix, and you're multiplying that by X. So the identity matrix times X is equal to A inverse multiplied by B. Now, remember, we said any matrix multiplied by the identity matrix is the original matrix. So the identity matrix multiplied by matrix X is going to give us matrix X. And matrix X, we can calculate it as the inverse of A multiplied by B. Very easy. Let's try this one. So we're asked to solve for the matrix Y in Q times Y is equal to Z. So if I want Y, matrix Y, to be on its own, I need to remove this multiplied by Q. The opposite of multiplying by Q is dividing by Q. So I'm going to have to divide by Q on both sides of the equation. But stop, wait a minute. We cannot divide matrices like that. So we have to use one of those hacks. I can rewrite this divided by Q as Q inverse, and then multiply that by our numerator, which is Q Y. And I can do the same on the right hand side of the equation. Rewrite this divided by Q as Q inverse times the numerator as matrix Z. Do you see the next hack coming into play? Q inverse times Q should give us the identity matrix I being multiplied by the matrix Y. And I'm just keeping back the order of the steps. Remember too, anything times the matrix I, which is the identity matrix, is that thing. So here we had I times Y, and that should give you just Y. So Y is going to be equal to Q inverse multiplied by the matrix Z. It's very easy. Once you practice and remember those hacks, you're going to be fine. Let's look at another example. Here we're being asked to solve for the matrix X in Px equal B. We need X to be on its own. So remember, when them each up so, it means that them multiply. So we can just put little multiply sign just to remind me. So I need X to be on its own, which means I need to remove that multiply by P. The opposite of multiplying by P is dividing by P. And if I do it to one side of the equation, to keep it balanced, I have to do it to the other side of the equation. Using hack number 1, I can rewrite this divided by P because we cannot divide in matrices like that. So I can rewrite this divide by P as P inverse multiplied by our numerator, Px. If I do that to the left, then I'm going to have to do that to the right. Rewrite this divided by P as P inverse multiplied by our numerator, B. And there you go. Hack number 2 comes in. P inverse times P gives us the identity matrix. And I'm multiplying that by the matrix X. And I'm just keeping whatever is on this side because nothing really changes over here. And the identity matrix times the matrix X will just give us the matrix X. So the matrix X is calculated by finding the inverse of matrix P and multiplying it by the matrix B. That's all.